If we want a computer to understand how to do something, we need to give it an algorithm.
Pick up brush.
Algorithm sounds like a big word, doesn't it? But actually, an algorithm is something very simple but important.
Pick up toothbrush.
An algorithm is a list of steps you give to computers to solve a problem or get something done. Imagine that you need to show someone how you brush your teeth so they can learn how to do it themselves. You would need to explain all the little steps you do in the right order so they can understand how to do it without getting confused. The instructions would go like this. 1. Open the toothpaste. 2. Put a bit of toothpaste on the toothbrush. 3. Open your mouth. 4. Brush your teeth nicely. 5. Rinse your mouth with water. 6. Smile. It is important to explain the right steps in the right order so you can get great results.
Okay, so now we're going to look at algorithms specifically for computer programs, which is how you're going to be using algorithms in class. So when you're writing an algorithm for a computer program, the first thing you do is you start by thinking of a person. Don't think about programming, don't think about computers. And you create a list of the steps you would tell someone to take in order to solve a given problem. Okay? So you're doing this just like you're telling somebody how to solve a problem. First do this, second do this, and so on. Then you take that list and you refine those steps to fit a computer and a programming language. And we'll look at how to do this in a moment. This algorithm, because that's now a computer programming algorithm, can then be given to anybody who knows how to program in this language, and they can use it to make a very specific program that solves the problem in the way that you wanted it solved. Okay, they can follow your steps. And basically, this is like, there we go. This is like an architect making blueprints of a house, of how to build it and where all the boards go and so on. And then the architect gives the blueprints to the builders, and the builders use them to build the exact house that the architect designed. So your algorithm is basically a list of steps, but ultimately it's a design for a computer program, for somebody to use to build a computer program. They're very informal. They're not supposed to be look good and be all lined up and perfect. They're kind of a mix of English and abbreviations and pieces of programming language that kind of sneak in. And that's how they're supposed to be. You're not supposed to spend a lot of time making them look good. You're supposed to spend time on the first step here of thinking of what the steps are. Okay? They're sort of like if you wrote them on the back of a cocktail napkin. That's how I think of them. So why do algorithms for computer programming? Basically, when you're writing a computer program, you're trying to solve some kind of a problem. You're trying to make the computer do something. And solving problems is difficult mentally. Programming is also difficult mentally. It's another thing that you're totally doing in your head. So now you're trying to do two things in your head at once. And as we all know, you cannot do that. You can only do one thing at a time. So this makes trying to problem solve and program at the same time makes the process very, very hard. And this can really make your programming take a long time. Okay? So what you do is you separate those two pieces. You take away the problem solving, and you problem solve when you're writing the algorithm. And you're thinking of what steps need to be, and then you're refining it for the computer program. Then you take your algorithm that's been refined for the computer program, and you put on your programming hat and you use it to write the step-by-step solution to your problem in the programming language. So you're just doing one of these at a time, and it makes life much simpler and it makes you much less crazy. So let's say that you are going to write an algorithm to solve a problem which you're ultimately going to use to write a computer program. Okay. Say you need a computer program that adds two numbers together and shows the user, whoever's running the program, shows them the answer. And the numbers, ultimately, those two numbers, they came from the user. So the first step is, again, to figure out how to do this without a computer and write these steps down, like you're telling another person how to do it. Then you take those steps, sort of a rough draft of your algorithm, and you adjust it to tell a computer using programming how to do this, whatever the problem is. And the result is you have a programming algorithm you can then use to write the program. So let's go ahead and end this PowerPoint and go over here and write this algorithm. So we're going to first start with the first step. Okay? Oops, let me get my pen. There we go. First step. How are you going to do this without a program? Or excuse me, without a computer program. So it's like you're telling another person. So you might say, okay, get the first number from the person. Some basic person that's giving you the numbers. And then get the second number from the person. Okay. And then add the two numbers together and show the answer to the person. Okay, so that's how you do it. Okay, that's how you get two numbers from someone, add them together, and then show them the answer. So now we're going to take that and do the second step, which is adjusting or refining this algorithm for use by a computer program. Okay, so let's see. Up here I had get the first number from a person. So, okay, I'm going to say get the first number from the user. And the user is who's ever running your program. And I'm going to put in parentheses, use a prompt. And that is a programming command that the language I'm using, that we're going to be using for class, JavaScript uses. So I'm thinking, oh, I'm going to do that with a prompt. So I might as well write it here, because then I don't have to think about it when I'm writing the program. Okay. And then I'll get the second number from the user, and I'll use a prompt. Now I'm sitting here thinking, oh, but I have to do this with a computer. That means I have to store it somewhere, because the computer won't remember what the first number is unless it stores it. So I'm going to store it in a container, which we'll learn about later. And I'm going to name the container num1. And over here I'm going to store in a container named num2. Okay, so now I've got my two numbers. So I look up at my algorithm. I've got my two numbers. Got that. Oops. Sorry. Got that. Got that. So now I'm on 3. Add the two numbers together. Okay, so I'll add num1 plus num2, and I have to store answer in a container that I'm just going to name answer, because that makes sense to me. Okay, so now I've got the numbers added, the numbers added together, and show the answer to the person. Okay, so I'm going to display what's in my container answer to the user, and I'm going to use a alert window. to do that, which is my programming construct or command. So this here is the algorithm. If I can draw my line here. Oops. Yes. Sorry. It's a new machine and it wants me to go through these steps. There we go. This is the algorithm for writing a program that gets two numbers from a user, adds them together, and shows the answer to the user. Voila, and you're done. And you can see how easy it is to write a program from this. I don't have to think about these steps. Now this is a trivial example, but when it's more complicated, again, I've separated thinking about the problem and writing the program. Enjoy.